I wanted to show you the mechatronics of the Speed T system. First thing I want to show you of the entire system is the power switch on this side, which you won't be able to see when I'm on that side. That's right there, simple push button for power, which we'll use in a little bit. The power that is controlling and powering this entire system is the 12-volt battery located here. We will take the power current from that battery, go into here, which is actually ran through the switch that I just showed you. If the switch is on, the power will go through that and go into the microcontroller. From the microcontroller, the power then goes into the breadboard through the black and white wires seen there. The first sensor I want to show you that is part of this kind of controls, if the system moves or not, is the purple and black here. It actually goes inside the T itself. I don't know if you can see down inside the T, but the photoresistor is within that T right there. So essentially, if there's a ball on top of the T here, there'll be a low light value. The system will not move because the ball is there. If the ball is removed from off of the T, it'll sense a high light value and then kind of put the system into motion. Second sensor I want to show you is the Halifax sensor located here, and then connected, actually glued onto the motor wheel itself, is the magnet. So as the motor rotates, the motor wheel rotates, the magnet will also move with it. And when it comes back up to the top, it'll stop because the sensor senses the magnet and sends a voltage reading to the Arduino. So this is our breadboard, and we have power coming in. We have the different sensors that I just showed you coming in, and then the Arduino there. We have one analog input, that is the photoresistor inside the T. The digital input is the Halifax sensor, and then we have one digital output, which is a brown wire coming from Arduino, pin 12 I believe, to the motor controller, so that when we are ready for the motor to turn on, it will send digital output to the motor controller, which will then send power through those wires there into the motor, and will move our entire system. So yeah, the mechanics of this system, the motor wheel has a little knob on it right here. As that rotates, it moves this entire link down, which brings the T and T assembly down, and it's kind of guided on that channel there. They'll come down, grab a ball that's in this tube here. The balls get fed into the hopper, which I'll do right now, and they get fed down into the tube, and they get ready to be loaded onto the T. So the first thing that needs to be done to power up the system is obviously turn on that blue switch that I showed you. So I'm going to turn it on. Right away it senses a high light value, meaning that there's no ball in the T. So it goes down, grabs the ball, comes back up. At this point the sensor is reading a low light value because the ball is on top and blocking all the light, obviously. So right now the system is stable. It is reading a low light value, so nothing's happening. So me taking the ball off the T right now is representing someone hitting the ball off the T. So I'm taking it off, somebody hits it, senses a high light value, goes and grabs another one. So I want to kind of zoom in here on the mechanics of it. Right now I'm taking the ball off. You can see the motor turns, brings that link down, and brings it back up. And it stops when the magnet hits the Halifax sensor there. So I'm going to show you kind of how the ball gets picked up here. The T gets brought down, grabs the ball, and gets brought back up. Not shown here, obviously, is going to be the platform that the person stands on. That will be shown in the video after this. So one more time, hitting the ball off the T, the system moves, brings the ball back up, and stops. That is the mechatronics of Speed T. Now this short video shows how Speed T could be used on an actual driving range.